All right, so I'm going to do temperature TSD in leopard geckos, which is temperature sex determination. That's actually a picture of one of my baby geckos right there. Her name is Snow. So TSD is temperature sex determination. Basically what that means is that in leopard geckos, the sex of the offspring is actually determined by what temperature the egg is at when it's incubated. 88 to 90 degrees Fahrenheit will produce mostly males, 80 to 85 will produce mostly females, and between 86 and 87 you usually get about a 50-50 mix. Now, when I say like 88 to 90, that doesn't necessarily mean that 100% of the offspring will be males. The further you get toward that 90 degrees, the higher percentage of males you will get. And as you go back toward 88, you're going to get a higher percentage of females relative to the other temperatures. So it's kind of like a range. There's also a thing, though, called hot females.
Now be careful with this one.
If you go above 90 degrees to 92 degrees, you will actually start to get more females again. Even though that's a higher temperature range. They're still working on why exactly that happens. They haven't figured it out yet. Previously, it was thought that 90 degrees was the upper critical temperature for leopard gecko egg incubation and that the hatchlings wouldn't survive. But on accident, they found out that they will survive. Then once they did survive, they thought, well, those females are probably sterile. But it turns out that they were actually just more aggressive, so it was harder for the males to be able to mate with them because they were violent toward the males.
Do you know what it's called when you discover something that you weren't looking for? Like you just gave an example. You know, there's a word for that, and there's some of the scientific discoveries were discovered through this phenomenon. Okay, serendipity. Yeah, penicillin was discovered by serendipity.
So how does temperature sex determination work? Sex is determined during the thermosensitive period, which is supposedly the middle third of incubation. However, it's arguable whether that is actually the thermosensitive period, just because at the lower temperatures, the incubation can take up to 100 days, but at the higher temperatures, it can be as short as 36 days. So being at a higher temperature will actually shorten that thermosensitive period, so you'll actually leave it quicker, whereas you actually wouldn't incubate during the entire thermosensitive period if it was at a lower temperature and you had that longer incubation period. So scientists are kind of arguing right now about whether that's actually the thermosensitive period, just because the thermosensitive period is different for every different temperature. The mechanism of why temperature sex determination happens is unknown as of right now, but they are trying to figure out why it happens. It's very common in lots of reptile species. There are a few reptile species that are GSD, which is genotypic sex determination, like people and mammals and stuff like that are. But a lot of different reptiles, snakes, turtles, crocodilians, lizards are TSD. So they're putting more effort into studying why exactly it happens as far as the mechanisms behind it. 79 degrees Fahrenheit is commonly considered the lower critical temperature for leopard geckos. Below that, the eggs probably won't develop fast enough. And at 93 degrees Fahrenheit, it's considered the upper critical temperature. And what happens there is that basically the development process happens so fast that things go wrong and the baby never ends up being able to get out of the egg. As far as other species go, the American alligator is probably the most studied besides leopard geckos, and the reason for this is that American alligators are used as a food source in lots of southern cuisines. I don't know if any of you have ever had like alligator nuggets or something like that. So alligator farmers are actually trying to figure out how they can more successfully control the sex of the offspring that they're producing. And that's just for like breeding reasons and stuff like that. There's also a species in Australia called bearded dragons, and they are genotypically sex determinate, but it was discovered that under extreme low temperatures or extreme high temperatures, they can actually become temperature sex dependent despite their genotype. So they actually they had male genotype lizards that had female sex characteristics and could actually become pregnant and lay eggs, despite having, I think it's ZZ for bearded dragons is what male genotype is. So these lizards had the ZZ genotype, but because of the temperature that they were incubated at, they ended up being females.
Okay, wow, the world's more complicated than I thought. Now, so it's temperature, sex determination, right?
Mm-hmm.
And then it's genotype, sex
Genotype,
determination.
sex
Is there another category, or is that basically
So far,
two?
those are the only two.
Only the two, yeah.
And that's actually, that bearded dragon is my bearded dragon. His name is Smog.
Smog?